All right, guys, welcome back. So I'm making some changes. So I printed out a bunch of these commutator cores. Some have, I don't know if you can make that out, they have flat spots on them. I don't know if you can see that. Yeah, you can see that. They have flat spots on them. That one has four, this one has three, and the one I have on there has two. The flat spots make it very easy for me to glue the copper on, which was one of the best buys I ever did. I don't know why I haven't bought sheet copper long ago. I think because I was a scrap hound guy and I didn't want to buy anything. Anyway, so I'm now working on this. I soldered a wire to, this is the steady state connection, which is going to go on this side. I know a lot of Newman motors have both connectors on the same side. I don't like that. I also made a new arm with a copper tab and it will sit up against there. But this guy will go, oops, this guy will go down inside there. This will go over it and I'll push it up in such a way where it will be maybe like a millimeter above there and I have a spring action. And then it will sit underneath here and I will connect that wire to the appropriate connection. That's really cool. I would love to rig up something. I did have a viewer talk to me about how they made one out of a copper pipe, and that to me that went off like that set off bells. It's like, yeah, copper pipe. That's probably a really good way to do it. That is my charger for my for my Makita battery. When it gets done, it plays some stupid that song. Dun 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 dun. Dun. Anyway, sorry about that. Anyway, so I'm going to start off with the two, and someone else asked me how do I calibrate it. I just do it by feel, basically. I set it up, turn it on. If it doesn't work in that position, I move it a little bit more. I've noticed that it works best when the poles are facing vertical and then these guys, the two tabs, are facing horizontal. And just so you guys know, this is one heavy rotor. There's 9 barrel magnets in each side. So 9 barrel magnets facing north, 9 barrel magnets facing south. And I made a protective shield to go over the top of this when I do fire it back up. So I'm waiting for this to cool. I just soldered the wire to the end of this guy. Now I got to figure out how I'm going to, I drilled a hole so I can put something in there so that when I push it down, it has some spring action. But I got to figure that out. So stay tuned. Oh, and I haven't forgotten about my solenoid motor. I've got to wind the 3 coils. It's a mess. I really got to clean up my shop. It's just disastrous. Anyway, stay tuned. All right, welcome back. So just so you know what I'm doing, this is what I'm doing. So this has got a little spring action in it, and it's going to sit up underneath there and press on that bar as soon as everything dries. So I will connect that. I think that gets connected to, it gets connected to the top coil, this guy right here, the top coil, the the finish of the top coil. But that's pretty cool. And I can probably use it for a lot of other things. I got to make sure that it's in there straight, though. It's kind of crooked, but it's all right. You get the idea. So let me get this thing all set up and see if we can get a first run out of it the way it was really meant to work. All right, stay tuned. All right, so I can get it going, but 2-prong one I don't think works very well, so I'm going to try the 3-prong. It's really finicky in order to get it going. That thing works great. Let me turn it off. Yeah, it's really finicky to do the I don't know, the two-sided commutator, the 2-pole commutator, if you will. I have to really play with it in order to get it going. So let me create a couple of more. And it might be too that the contact isn't wide enough, because in the old one, when it went really well, the contact was really wide and I did like almost a third of it. But I was, yeah, just experimenting around with different size commutators to see what's going on. Stay tuned. So it appears the more the better. So I'm going to go back to the drawing board and print out another cylinder, this time with 4 contact areas and a little bit wider. This one only has 3 on it, and it's half-assly held together, but as soon as I turned it on, it started going right away. So yeah, this is working great. There's no issue with that. So I can get something going constantly at an okay speed, not super fast, but then Newman motors aren't supposed to go fast. So let me go back to the drawing board and print out a new commutator. Stay tuned. All right, so it's going much better with just one contact point, and instead of making the flat edges, I just made it round. And it's not really super secure on there, so it changes speed because I think it's turning. And I put my protective cover on there just in case. But yeah, it's going really good now. So this thing is working really well. And it's going at a decent speed. Let me see if you can see any of the sparks. I really can't see a lot of sparks. So yeah, right now I've got a couple of these printed out, but I'm going to scrap it because it's better with just the round on there. With these flat spots, I thought maybe the copper would take up the space and make it round, but it doesn't. But yeah, she's working really good now. Uh-oh. Slowing down. Kinda. Like I said, the commutator's not really held on there too tight. Yeah, it slows down, then it speeds up. If you guys know why it's doing that, let me know. I think this thing is just finding its center point, because it is kind of loose on there. Although I don't know if you can see it, I stuck a small, not a nail, but a pin in there. Yeah, it's staying at a pretty good speed. I gotta cut this off. I want it to be nice and round. Presentation is everything, right, guys? But yeah, so I got it going pretty good now. And I didn't even really, I just put it on there and started it up. I didn't even like calibrate it. So let me stop it and kind of calibrate it and see what happens. Hold tight. So it seems that in calibration and the timing, if you will, when the poles are pointing straight up and down, if I make the contact also straight up and down, so a contact on top, nothing on the bottom, that seems to do the trick. Let me put it in a different position and see what happens. Hold tight. So I'm starting to figure out that I don't really think it's so much the position, although it is. It's the width of the contact. Because I can put it if I put it horizontal in comparison to the vertical rotor, it doesn't work very well. But now I can go in either direction. I can go this way or that way with it. Hold tight. Yeah, so the best position, the timing, is when both pole and contact are vertical. Yeah, vertical. That seems to be the best. Now I just have to figure out the width of the contact. Does that make a difference? And I'm positive it does. Because when I tried these thinner ones, I didn't get anywhere near this type of speed. So it's making more contact. But it's a nice setup. I like it. Nice and simple. All right, let me try putting 2 contacts on the larger spool. See what happens. Stay tuned. So this has 2 contacts on it on opposite sides. It doesn't seem to work very well, and I didn't think it would. It's also not stuck down very good. Let me stop it and fix it. Stay tuned. So it's really weird. I have a question for you guys. So when I have the single contact on the commutator, so just one strip, the motor wants to go this way, which facing would be clockwise. When I put the 2 strips on the opposite side, still in the same orientation, now it wants to go counterclockwise. And obviously you can tell it doesn't want to go as fast either. So I think what's happening is it's working against itself. See the little spark there? I don't know if you guys can see it. And the carbon's leaving a little black ring on there, which is fine. I expected it would. So it's making double the contact going about half the speed in the opposite direction. I have to sit down and think about this. All right, stay tuned. So this is going back to a single contact. And obviously you can see it's about twice as fast going in the direction I want it to go in, which would be counterclockwise. It's slowing down a little bit. I don't think I'm getting good contact over here either, because when I lift this up a little bit, I get a faster speed. I'll have to work on that. It's still working really well. You can see right now it's working really well. But yeah, the single contact seems to be the, excuse me, the way to go. And about a quarter of the size, a quarter of the width of this. That seems to be the optimal calibration or configuration or setting, or whatever you want to call it. Yeah, to get a steady state where it goes about the same speed. I have to see now, I have to figure out how to set this up as a generator. I have the diagram. Little Zen moment there. It's working really well though. I got to get on winding the coils for the solenoid motor. All right, stay tuned. So I changed the position of the contact in relationship side to side. Because it looked like it was only making a connection on one of the corners there. Didn't seem to really change anything. Seems like it's going a little bit faster, but speed is not what I'm looking for. I want to make sure that this is making full contact. But yeah, that one commenter was right. 3 layers is all I need. Instead of that beast over there that's got 5 layers on it. Which I'm not getting rid of, by the way. I'm going to do something with that. Something later on. And I'm also going to print out some new rotors, because I made this again so that I could put multiple rotors in there with different configurations. That's a heavy, big rotor. All right, guys, stay tuned. So that seems to be the optimal setting right there. Because it's going fast enough where I needed to put the blast shield on there just in case. So yeah, one contact. Now I'm going to print out a couple more of these without these flats on them. I thought that would be a good idea, but it's not. And try different widths of the contact. Try a small one, try a big one, try one that's got half of it on there, so half of this is covered, and see what happens. So I'll bring you back shortly. Ciao. All right, this is with half of this covered. So half of the entire commutator is covered with copper. And I didn't even really set it up. I just kind of put it on there. I think it was facing, oops, I think it was facing where the covered half was vertical, in with the, in the same direction as the rotor. And that's definitely going faster. I'm trying to see if it's making, it seems to be making full contact. I don't know if you can see the sparks there. They're kind of on the right side a little bit. Let me see if I can move this just a little bit without messing it. Oops. Yeah, now it's contacting a little bit on the left side. Let me see if I could just slide that over. Yeah, so that seems to be the ticket. Now I just got to set it up as a generator. I probably should put this guy on there, just in case. Yeah, that's really weird. This guy's working great. I can move him, it doesn't really matter. He's making good contact. All right, now I just got to set up the generator. So I'm still going to experiment around. I'm reprinting these to get these edges off. Like I said, this was the original commutator. I took the outer shell off. This guy here, I took this guy off because I don't really need it. It makes too much, too hard of a contact, makes too much noise. Why is that at 13? I mean, 12 volts, exactly. Yeah, that seems to work really, really well. Just like that. So now I got to set this up as a generator to see what's happening. What kind of power I could be getting off of this. I'll have to go and take a look at the schematic. I'm not 100% sure off the top of my head how to set this up as a generator. I have an idea. But yeah, as a whole, this is what I wanted to achieve. I wanted to build a Newman motor that was big, had a heavy rotor, has a nice steady state connection using carbon, those things that they use in, I forget what they're called. I'm drawing a blank. I'm tired, man. I didn't get a good night's sleep. whatever they're called. Um, Using that, I've got it soldered in a base with a wire coming out, and then a nice commutator setup. This actually runs a lot better and faster on the JL94 circuit. A lot better and a lot faster. I don't know why I'm doing this. A lot of people yelled at me though saying, no, you got to have a commutator, blah, 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 blah. I'm like, why? But yeah, it's working really well now. This, like I said, this now has half. Here, let me turn it off. And I'll show you what I mean. Let me turn it off and turn it down. So yeah, half of the commutator is exposed, and it's not, I don't know if it's fully straight up and down. I don't really think it matters at this point. Let me just turn it a little bit. I don't think it really matters at this point. Let me turn this back on. Oops. Trying to do all this shit one-handed, it's a nightmare. It almost wants to self-start. Yeah, and then basically I just moved it a little bit. Changing the position, I mean. You know what? Let me try and do it in the complete opposite and see what happens. Stay tuned. I gotta turn you down so I can, or turn you off so I can set it up properly. Stay tuned. So that's in a horizontal state. Obviously, it's going in the opposite direction now, not as fast. And it actually self-started. I wish I had the camera going. It actually started up by itself. Here, let me see if I can get it to go the other way. No, I can't. Come on. There it goes. So now it's going in the opposite direction when I turned the commutator so that the tabs are horizontal instead of vertical, and obviously twice as slow. So let me turn this off. You know what? If I can just, okay. And now it's going clockwise. Clockwise in my mind, anyway. Yeah, it's going clockwise if we're facing this way. And back up to its normal speed. I'll have to put a piece of tape on there and get my tack out, see what kind of speed we're getting. I'm actually printing out some new ones that are smaller, not as wide, because I don't need it to be that wide. I didn't realize that until after the fact. All right, guys, stay tuned. So I actually did this by mistake. I put the collet on and tightened it down so that the little set screw is pointing up with the pole, and as it goes around it just touches the commutator, and it actually is running now at a steady state. Really slow, but if you look really closely you can see the sparks, because it's not touching the commutator the whole time. It's only touching the screw each time it revolves. That's really weird. And it'll go like this at 12.2 volts. It'll go like this forever. I hope it's not damaging the COM tab. No, because it's just going really slow. And so I think if that set screw was bigger or wider, it would go faster, but it actually works well. I wonder if I put them together. No, it's not going to make that much of a difference. But that's weird. 12.2 volts. And it's taking up almost no amps. Yeah, it'll just keep going like this. That's really weird. Because I thought about using one of these and figuring out how I could cover half of it with um, a substance that wasn't um, that wouldn't make contact with the metal. I'm losing my mind today when it comes to trying to think of the right words to say. Always happens when I'm making a video. Excuse me, let me get down here. Put this back. Yeah, so that's kind of cool. I just thought I'd show you that. It makes just enough contact to kick the rotor around. Cool. Later. You know, I just had a major brain fart aha moment. I now know why. And I realized it when I was explaining that this is vertical with the poles. Now it's going counterclockwise. It's because whichever pole is facing up. So if north is facing up, it's going to go counterclockwise. If south is facing up, it's going to go clockwise because, yeah, duh. So that's how I can change the direction. I don't know why I didn't realize that before. And this is actually going a little quicker. But yeah, I thought I would just throw that in there. It was a little bit of a brain fart when I was talking before. I couldn't figure out why it was going in a direction at one point, and now I realize I knew why. I just didn't think about it because I'm stupid. Anyway, all right, man. Stay tuned. All right, so here's one of the new commutators, the smaller width like I told you, and I realized that if I make it a quarter of the diameter, that seems to be a really good size. And what's really weird is this is on there really loose, because I usually take a small pin and stick it in between there to keep it nice and tight, but I don't have to. Oh, maybe I do. It's probably loosening up. Yeah, it's probably spinning out of its right position. I'm sure it is. Yeah, so I have to tighten up. But anyway, getting back to what I was saying, about a quarter seems to work. So let me get it secured in there and bring you back. Hold tight. Yeah, there we go. So that's the quarter of the size. The next one I'll try half the width, and I think half the width will work better. But I think it'll work just fine with a quarter. So I have to figure out a better way. You can see I got a little pin in there to secure it in there. But it's going pretty good. So now I just have to figure out how to turn this into a generator, which I know how to do. I just got to get the schematic and set it up with some LEDs and see what, or with a meter and see what kind of power we're getting out of this thing. All right, guys, maybe I'll do that tomorrow. All right, ciao.